Hey guys, Dr. Brown with Kubo Math coming to you from Tarlac City, Philippines. And tonight it's Calculus 1 with the coolest problem ever. Maybe not the coolest one ever, but it's pretty close. Okay, so let's get after it. Now I'm going to write a little bit smaller, so you may have to zoom in just a little because this problem is going to take the entire board. I hope I can get it all on the board. So let's see what happens here. Okay, we have two poles that have been set in the ground. They're 30 feet apart. This pole is 28 feet tall. This pole is 12 feet tall. Your boss has said, hey, use the least amount of wire as you can as a guy wire to tie this one to the ground and this one. You're going to use one length of wire and then stake it in the ground somewhere. So the question becomes, where should you stake it? What distance from that pole should you stake that wire so that this overall length of W is minimized? And W is Y, which is the hypotenuse of this triangle, plus the hypotenuse of the other triangle. Okay? So you can see we need to write the expression for Y, write the expression for Z, and that would be W, so Y plus Z. So let's set that in motion, and then once we get that squared away, then we can take the derivative of that, set it equal to 0, solve for X, and then after we solve for X, we can evaluate on each side of X to determine if we're at a minimum or maximum. Okay, so let's, if I don't trip over this cord, let me flip around here, see if I can manage this. Okay, so Y would be, since it's the hypotenuse of that triangle, that's going to be X squared plus the 12 squared and the square root of that. So Y equals the square root of, as a matter of fact, why don't we just, instead of writing the square root, why don't we just write it as to the 1/2 power? Because we know we eventually are going to need that. It's my new eraser. Okay. All right, so I've got X squared plus 12 squared, which is 144, all to the 1/2. That's Y, square root of that. Okay, Z would equal then the, let's see, this would be 30 minus X, right? 30 minus X would be that side. So 30 minus X squared plus 28 squared. Don't know what that is. And all of that's to the 1/2. So W then, the length of the wire, is the sum of those two. Okay? So let's see if I can get that down here. So W equals, I bet I cannot. Let me just go up top. See if I can flip around here. I wish I had a wireless mic. Maybe one day. Okay, so W equals Y plus Z. And so I may move over just a little bit. W equals X squared plus 144 to the 1/2 plus Z, which is 30 minus X squared plus 28 squared, and all of that to the 1/2. Well, let's see. I may need to scoot over a little farther. All right, W then equals, I'm going to expand that just a little bit. So I've got x squared plus 144 to the 1/2 plus 30 minus x squared. So 30 times 30 would be 900 minus 60x plus x squared plus 28 squared, and all of that to the 1/2. Okay. Obviously there's some terms we could gather together, but for now let's just leave them as they are. Now, okay, dw dx. So 1/2 times the parentheses x squared plus 144. So 1/2 minus 1, so now a negative 1/2. Chain rule times what's inside, which is the derivative of what's inside, which is 2x. Derivative of x squared is 2x. Derivative of 144 is 0. Okay, plus, now we have a similar situation. 1/2. I'm going to move some things around here. I'm going to move the x squared minus 60x plus 900 plus 28 squared, and all of that to the minus 1/2 times what's on the inside, which is, I have to put it here, 2x minus 60. Okay, we're going to have to move over a little farther, it looks like. All right, dw dx equals, let's kind of straighten up some things here. We have 2x over this 2 right here times 1/2. And you can see that I have x squared plus 144. I'm going to move the negative 1/2 out of the numerator, put it in the denominator so it becomes a positive 1/2. Those 2's cancel. Plus, I've got 2x minus 60. Actually, I'm going to factor that into 2 times the parentheses of x minus 30. 2 times x minus 30, which is 2x minus 60. Because I have this 1/2 here, I need to get rid of the 2's here. All right, so that's times the parentheses. Oh, that goes to the denominator. So that is x squared minus 60x plus 900 plus 28 squared to the 1/2. Okay. Now then, all of that equals, set it equal to 0. So I'm going to subtract, well actually let me get a common denominator first. So these 2's have canceled, those have canceled. I'm just going to wipe them out of there, kind of clean up just a little bit here. And I probably need to clean that up right there. So that's 900 plus 28 squared. Okay, if that equals 0, I'm going to subtract this from both sides. Oh, before I do, let me get the common denominator. So obviously, I need to multiply this side by that, and then this times that side, and then put it all over this. As a matter of fact, let me just do it right there. So this would be x squared plus 144 to the 1/2. And then this one would be x times all of this, x squared minus 60x plus 900 plus 28 squared, all to the 1/2. And that's a plus right there. And all of this, all of that is over x squared plus 144 to the 1/2. So that's my common denominator. All of this plus all of that. Now you'll note, since all of this equals 0, the only way that can happen is the numerator equals 0. So I can take that, all of that numerator, I'm going to subtract this and put it on the other side. So let's move over even further here. 0 equals, actually dw dx, that equals 0. But I'm going to subtract. So I've got x times x squared minus 60x plus 900 plus 28 squared. And that equals, if I subtract that from both sides, I can multiply this by -1. So I end up with 30 minus x. So 30 minus x times x squared plus 144 to the 1/2. So it was equal to 0. I subtracted that from one side. So this now equals that. Okay. For now, I'll just leave the denominator right there. And we're going to work with these numbers and set it equal to 0 and see what we can do. Well, first off, this should be to the 1/2, and that's to the 1/2. You should have been screaming into the monitor, no, you missed it. You'll find this in calculus. The algebraic oopses is really where we mess up. Because there's so much algebra involved. And I'm trying to get it all on the board, so I'm scrunching it up. And I don't know how good that looks from your home, but hopefully you can zoom in and it's okay. Now, okay, I have a square root sign and a square root. I want to get rid of those. So I'm going to square both sides. So when I square both sides, that goes away, that goes away, this becomes squared, that becomes squared. Okay, now then, I can use the distributive rule and distribute that x squared into all of those terms. Okay, matter of fact, what is 28 squared? 28 times 28, 64, 6, 16, 22. 2 times 8 is 16, carry the 1. 2 times 2 is 4, and 1 is 5. 4, 8, 784. So that number is 784. That looks terrible. 784. All right, let me wipe that guy out. Put that as a 784. And you'll see in a moment why I'm not adding those together. All right, so x squared times x squared, I'm going to distribute that in, gives me x to the 4th minus 60x cubed plus 900x squared plus 784x squared. And that equals, 30 minus x. Let's see, squared. 30 minus x times 30 minus x. That's 900. Now you see, 900 minus 30x is minus 60x plus x squared. Okay, I'm going to flip that around. That's x squared minus 60x plus 900 times x to the 2nd power plus 144. Okay, so I have x to the fourth minus 60x cubed plus 900 x squared plus 784x squared equal, okay, I'm gonna distribute this one inside. So x squared times x squared is x to the fourth minus 60x cubed plus 900 x squared. Now I'll distribute the 144. So plus 144 x squared minus 60 times 144 times x. Can we still see that? Oh boy. Plus 144 times 900. Now as I work through this the first time and I'm multiplying these things out with my calculator, I'm thinking, obviously I've missed this somehow. Because the numbers like 144 times 900 is some 129,000 or some crazy number. It's big. Okay. Now, but it was correct. Okay, so let's keep rolling. Now then, I'm going to subtract x to the fourth from both sides. So I'm going to x to the fourth minus x to the fourth minus x to the fourth. Okay, that goes away. Now I'm going to add 60x cubed to both sides. 60x cubed goes away on both sides. Now then, I'm going to subtract 900x squared from both sides. Now you see why I didn't put those together. Okay, now then, I'm going to subtract 144x squared from 784. So that leaves me 700 minus 100 is 684. So it's 680. So that leaves me 680x squared. So that was that term and that term. Now then, 60 times 144, let's see, 144 times 60, bring down to 0, 6 times 4 is 24, 2, 24, 25, 26, 2, 6 times 1 is 6, 7, 8, 8640. So I'm going to add 8640 to both sides plus 8640x. Okay, so that took care of this guy. It was a negative and I added it to both sides. 40, that's a 0. Okay, minus this 144 900, or 144 times 900, and that equals 0. That's not right. That should have been 640. Sorry. Okay, now then, if you look through this, I started trying to factor out some of these, and 640 divided by 2, you know, if you're doing 640 and you're trying to find the prime factorization of that, okay, it came out to 320. So I just as a guess said, well, okay, if I factor 320 out of that, will that go into these? And the answer was yes. And it ended up being 2x squared. 320 would go into that 27 times x minus 405. And that equals 0. Now if I divide both sides by 320, obviously the 320 goes away. Well, 320 divided by 320 is 1 times all of that is all of that. 0 divided by 320 is 0. So that's how I derived at that equation. Now then, here we are. my big eraser. We have 2x squared. 2x squared plus 27x minus 405 equals 0. Well, 2x squared times negative 405 gives me negative 810x squared. So I need to factor 810, knowing that it's a negative, this is a negative, so I need to factor this guy, knowing that the positive number has to be greater than the negative number, because it has to add together to give me a positive 27x. So I started factoring this. I'm just going to factor 810. Okay, divided by 2 is my 405. Divided by 5. By 5 gives me 81. Divided by 3 gives me 27. Then 3 would give me 9. 3 again would give me 3. 3 again gives me 1. Okay. 5 times 3 is 15. 15 times 3 is 45. Okay. 45 times 9 times 2 gives me, or 45 times 9 gives me 405. So if I were to take this and factor it, is 45 and 9, and make the 9 negative. So I've got, this factors into 2x times x is 2x squared. So now you know the drill. 45 times x is 45x. Negative 9 times 2x is minus 18x. Add those together, you get 27x. That's 2x squared, and that's a positive 27x. And negative 9 times 45 gives me the negative 405. So that factors into 2x plus 45 times x minus 9, and that equals 0. We're getting there, okay. 9 minus 9 equals 0, so x equals 9. So 2x plus 45 equals 0. 2x equals negative 45. Oh, divide both sides by 2. X equals negative 45 over 2. X, man, can I have a negative distance there? No, I cannot. So this makes no sense right here relative to the problem at hand. So we're throwing that out. X equals 9. It's saying if I'll put x at 9, which 30 minus 9 is 21, so this would be 9, this is 21. So we want to say, however, we've also studied about relative minimums and maximums. It's saying I need to minimize that wire length. Did I? Is it minimized? Well, I don't know. Well, I took the derivative here, so I have this guy right here that I could, in fact, put this back into the equation and see if I can solve it. Actually, dw dx, it'd probably be best to just stick it in right here, wouldn't it? At either place, we can do that. So let's see, I've got x equals 9. So here we are. X could be, it has to be greater than minus infinity, but less than 9. But also x could be greater than 9 and less than positive infinity. I mean, obviously we're bound. That's not quite true. X could be 0, but it's bound by can only be 30. I mean, if x is 0, the other distance is 30, so we're really bound here. So it had to be less than 30. So let's put it equal to 30. So we have x equal 9 in here somewhere in the middle of all of this. So if x equals 0, that side gets wiped out. 0 minus 30, that's a negative number. This would be positive. Okay. X is 0, so that's 0. Square root of 144, that's a positive number. 0 minus 0, that's a positive number. So this is a negative over a positive. So if x is 0, this thing is a negative. Okay? So f prime of x is negative. Alright, so remember 9 is right in here. Now if x is 30, what happens then? 30 minus 30 is 0. That goes away. 30, let's see. 30 squared is 900. So we got 30 times that. 900 minus 60 times 30 is 1800, right? 60 and 30, 18, yeah, so 1800. So that's a negative 900 here. Plus 28 squared, which was, we have 784, wasn't it? 784. So that's negative. Okay, I confused myself for a minute there. So 30 times, parentheses of 30 squared is 900, minus 900, or minus 1800 is negative 900, plus 900, that's 0. So all of that has canceled itself out here. So now I have 30 times 28 squared, so that's a positive number. So all of that's positive. Okay, so, and we're all over 30 squared, that's positive. Again, we're back to that same scenario, and that's positive. So now, f prime of x, if x equals 30, it equals a positive number, so it's increasing. So it's telling me that on either side of 9, you know, I've got a negative over here, a positive over there, which says that's a relative minimum. So there you have it. So if we want to minimize the wire length, we can let x equal 9, and that will do the trick for us. X is 9, 30 minus x is 21, so then y plus z, that would minimize w. Of course, you can put 9 back into that, and you can solve for the overall w length. All right, this was an awesome problem here. I really enjoyed this one. Sorry for the mess, but I wanted to try to get it all on the board, so hopefully you can zoom in and check that out as we went along. And sorry for the big numbers too, but that's just the way it was. I tried to just not multiply out as much as I could to try to not screw it up and have to do it over and over again. So this worked out okay. Okay, why are we doing this? We're crazy. That's why we're doing it. We're doing it because we want to help you get better at your math so that together we can build a better tomorrow. That's what we want to do, and do that through math. If you can start mastering things like this and grow your mind, you'll get better on the job. Hopefully you can get better jobs, but being better on the job you have now could lead to better things. So let's focus on solving these, growing our mind, getting better and better and better. And how do we do that? We study, we study, we study, and we work problems. Okay, that's all for now, and have a great evening, and we'll talk to you next time. Thanks.